Bright QT. Every student matters.
After understanding these physical properties, let's understand some chemical reactions that are shown by ethanol. So the first chemical reaction that is shown by ethanol is esterification. It's a special reaction shown only by alcohol and ethanol. So here, we are using ethanoic acid and ethanol, but you should keep this in mind that you can be using any kind of alcohol and any kind of carboxylic acid to proceed with this reaction. What happens here is that there is this OH group at the end, and there is this OH. So let's just write it simply, right? So it will be CH3C double bond O OH, and this is CH3 CH2 OH, right? So this is ethanol and this is ethanoic acid. What happens is that in the presence of a dilute acid, these two react, and this H is lost from here and this OH is lost from here, and this combines here, right? So you can consider this whole thing goes and attaches here, and this new compound that is formed is called as ester. So you can see it here that the OH was replaced with the this side of the ethanol, of the alcohol. So if the chain can be as long as you want on either side, it can be any form of alcohol or any form of carboxylic acid. The compound will always be called as an ester. Ester is this compound with a very fruity smell. It is used as a flavoring agent. It is also used to make perfumes because of its beautiful smelly nature. And this reaction is also very important. It may seem complicated because it has a lot of elements involved, but it's very simple. From the carboxylic acid, you remove the OH. From the alcohol, you remove the H, and then you join the two ends which have valency remaining, and that is what you will come out with a ester, right? So this reaction is esterification. So for this activity, what we will do is you will pour 1 ml of ethanol, which is absolute alcohol, in a test tube. Pour 1 ml of glacial acetic acid and alcohol, and then a few drops of concentrated sulfuric acid. Once you've mixed all these three substances in the test tube, we will pursue with this activity. Now, warm the contents of the test tube in a hot water bath for about 10 minutes. Using a clamp stand, we will hold it and we will heat the content of the test tube for about 10 minutes. Then pour off the contents of the test tube in another beaker containing 20 ml of water. Now smell the contents of the beaker. You will realize that there is a sweet fruity smell. This smell is due to the formation of ester ethyl ethanoate. This process is called as esterification. So this sweet fruity smell is being released due to the formation of ester, which is ethyl ethanoate, and we have combined the alcohol and the acid to create this ester. This can also be reversed, and that is a separate reaction. The same reaction can be reversed in a process of saponification. It is called saponification because it is used to make soaps. So the ester, when presented with NaOH, reacts to give back alcohol and to give back the acid, but it reacts with the Na and forms a salt. So this reaction is used to form soaps, and that is why it is called as saponification. Then this reaction with hydrogen carbonates and carbonates. So acetic acid or ethanoic acid reacts with these compounds. As you have seen here also, it has the capability to form compounds with sodium. Sodium is highly reactive. You have to keep this in mind. This is acidic in nature and this is basic in nature. Right? So even though it is a weak acid, it does not show all the reactions as you would expect, but it reacts with a strong base of sodium, basic nature of sodium, and forms this salt along with water and carbon dioxide. So it reacts with both Na2CO3 that is sodium carbonate and sodium bicarbonate or sodium hydrogen carbonate, to form salt and release water and carbon dioxide. Right, so we have studied two important compounds of carbon. One was ethanoic acid and the other was ethanol. Ethanol is an alcohol group, ethanoic acid is an acid, is a carboxylic acid which shows weak acidic properties. We have special reactions like esterification, saponification, and also reacts with carbonates and hydrogen carbonates as expected because of its acidic behavior. Now let's move on to this topic which is off related. So before we enter here, let's just revise. We studied how does carbon exist in nature, its free forms, its compounds, in which we studied saturated, unsaturated hydrocarbons, we studied various functional groups, and we studied their nomenclature. From the nomenclature, we moved on to the chemical properties of carbon compounds, and then we moved on to two specific compounds of carbon, ethanol and ethanoic acid, and we studied their properties separately.